Hello everyone, and thank you for joining today. I'm Nikhil Kassetty, and I'm here today to talk on a topic from milliseconds to microseconds, how quantum computing could transform real-time payments. So, to start with, we are at a fascinating intersection of two major revolutions. It's more of like real-time payments and also the quantum computing. So in today's talk, take you through how the quantum computing a technology once confined almost like to just, I would say, more of a theoretical physics model is now beginning to reshape one of the most critical pillars of our economy and also the financial transactions. So as we move from milliseconds to microseconds, we are not just talking about faster payments here. So we are also talking about a shift in how value is exchanged globally. So more about like how fraud is prevented in real time and how banking systems are re-architected to operate in the quantum speeds. So imagine like in this billions of transactions per second optimized across global networks with fraud detection systems that don't just react, they also anticipate. So the potential economic impact of this transformation is just staggering, I would say. So just because I'm just saying that based on the studies that usually suggest this. So the studies in the recent ones that I've went through suggest more of like around 411 billion global boost, and that's just not only the beginning. So as part of that, in this presentation, I'll walk you all through the core quantum principles that makes this possible and at the same time, the real world pilot programs that are already in motion and also the use cases in payment processing, fraud detection, and risk management. So as we move through the next slide, so here we are going to discuss more of quantum principles, also the quantum day, or like how it is approaching, and also the global initiatives. So to start with, on I would say like a quick primer on the quantum computing, it's just more of not just a theory anymore, at least for finance now. So at its core, the quantum computing operates very differently from classical machines now. So instead of traditional bits that are either 0 or 1, like the quantum bits or qubits, that can still exist in more of a superposition way. That is both 0 and 1 at the same time. So that is the difference here. So combining this with the entanglement and the interference, we can get a system that can explore massive solutions and also the spaces in parallel. So what does this mean for finance? So it means we can solve problems that are currently intraceable or like optimizing, I would say, global payment routes. So it's more of simulating economic systems and also detecting the fraud in real time. So now you may have heard of Q day. If not, so the Q day is the moment when the quantum computers surpasses the classical ones in commercial utility. So that day is almost approaching faster than expected. So we are seeing a lot of breakthroughs in error correction, stability, and qubit scaling from major players like IBM, Google, and D-Wave. And that's not just a thing. It's more of not just the tech giants pushing the frontier. Even the financial institutions are getting involved too. So one key initiative is by the Bank of International Settlements. It's called BIS. So working with the central banks of France and Germany on a more of a quantum leap project. So it's more focused on transforming cross-border settlements and also more of in a monetary infrastructure. So as we move through the next slide, here we are going to more of talk about the fundamentals and also different kinds of payment systems. So here the I would say here it more likely works as a foundation of why quantum really matters in the payments. So the quantum computers use qubits which can exist in multiple states at once. So I would say the quantum properties like superposition and entanglement that we were discussing earlier, they give the ability to solve problems exponentially faster than the classical machine. So in payments, that means we can optimize routing, detect fraud faster, and also they handle massive transaction volumes. And it's just not theoretical. As I was mentioning, the Bank of International Settlements is already leading the real world pilots focused on cross border quantum payments. So these early experiments are helping shape the quantum ready infrastructure for tomorrow. So now let's explore how this impacts payment speed and processing in general. So As we move through the next slide, here we discuss about the accelerating this payment processing. So this is where the quantum systems start delivering real visible impact at accelerating payment processing end to end. So traditionally, payments move in batch cycles, so often delayed by processing windows, also like the settlement queues and also the routing inefficiencies. So with quantum computing, we are looking at a more real time or even microsecond level transaction. So leap that changes how money flows across the globe. So through quantum enhanced routing, payment systems can instantly evaluate billions of possible paths and select the most efficient one, and also the factoring in the currency conversion, regulatory constraints, and also the network congestions. So on a global scale, this means the seamless optimization across banks, regions, and also the digital networks minimizes this friction and also maximizes the speed. So finally, the impact on the settlement speed is more prevalent now. So I would say more important and at the same time more, I would say, like much required. So what currently takes hours or days can even be reduced to milliseconds or microseconds, dramatically improving this liquidity, reducing risk, and also the enhancing the customer experience. So the quantum doesn't just makes the payments faster, it also makes the entire financial network smarter and more adaptive and also future ready. So the next slide, we are going to discuss about enhanced fraud and detection prevention. As part of being future ready is just more of staying ahead of threats. So quantum computing enables an entirely new level of fraud detection with quantum sorting. So we can process massive financial data sets in real time, detecting anomalies, patterns, and also the risk factor than even before, and also making it faster. So instead of waiting for fraud to occur, the real time monitoring allows us to flag suspicious activity even before the transactions complete. So this is proactive and at the same time reactive security as well. So then when it comes to AML, so AML stands for like anti-money laundering. So the quantum analytics vastly improve how we identify and trace these suspicious financial behaviors, even across the complex transaction chains and also the hidden networks. So with quantum, we are no longer limited by scale or speed. We are entering an era where fraud detection becomes instant, intelligent, and also global. So how do we see this transformation can happen in the management, right? So it just doesn't stop with fraud. So quantum's power extends deep into financial risk management, reshaping how we assess, price, and predict risk at every level. And also at the top of the stack is the portfolio optimization. So the quantum systems can analyze massive combinations of assets, constraints, and also the market variables, producing optimal strategies in microseconds, not just hours. So next is the asset pricing. So where this traditional model simplify to make calculations more tractable. But quantum algorithms can incorporate far more variables, leading to the quantum level precision in the valuation. The next thing what we have is the risk assessment. So whether I'd say like whether in the market, credit, or operational risk, quantum tools allow us to simulate uncertainty at scale, improving accuracy and response time for risk managers. And also finally the consumer analytics with behavioral data. Exploring the quantum computing helps us understand customer patterns and the preferences in more real-time way, powering more personalized and predictive financial services. So altogether, this is just not like an upgrade that we are looking at in speed, but it's more of like a paradigm shift in how financial institutions quantify and manage risk. So the next important thing would be the security that we are going to discuss. So when we come to the security aspect, I would say while quantum computing opens the door to massive financial transformations, as we were discussing earlier, it also introduces the security issues. What we call the quantum security paradox, right? At the heart of its encryption, so the financial systems rely on RSA and also the ECC cryptographic methods. so that quantum computers can break with enough qubits and time. What we really consider secure today could become more instantly vulnerable in a post-quantum world. So even more concerning is the rise of the harvest attacks. So these involve bad actors collecting the encrypted data with the intention of decrypting it later. But once the quantum capabilities catch up, these includes these sensitive transactions, personal data, even interbank communications. That's why building a quantum safe infrastructure is more required and urgent, I would say, when financial institutions need to adopt post quantum cryptography and also the algorithms resistant to quantum attacks. So this gives a more of a beginning of the transactions well before quantum computers reach the full maturity. So the security aspects must evolve parallel with innovation. Otherwise, the very technology that empowers finance could also expose it. So as we see here, so when we discuss the total adoption, how it is right now, it looks at different industries are trying to adopt this. And also at the same time, different industries, as in like in the financial sector. So the financial institutions which are running experiments with the quantum applications, especially in the payment processing and also the portfolio modeling. So these pilots help them understand performance, integration, and scaling challenges. So the payment networks are just stepping up so that the focus will be more on developing quantum safe protocols to ensure future proof encryption and also the secure transaction flows. Meanwhile, the central banks are exploring how quantum can enhance settlement systems, reduce latency in clearing process, and also improve global liquidity alignment. Of course, the implementations isn't just without challenges, but qubits remain fragile, hardware is evolving, and also the timelines are still uncertain. But these pilots are planting the seeds for quantum native financial infrastructure. So, what is the takeaway as we see here? So, we are moved beyond curiosity. We are in the more of experimentation era. So, and so like those who start now will have a serious competitive edge with the quantum computing as it more matures in the overall system. So, how do we prepare for the quantum payment future? So, as we see, it's more of starts with a strategic roadmap. The financial institutions are beginning to define what quantum readiness looks like. So, from assessing the talent, they need to identify where quantum can create the most value. So, there's more about like long term capability building, not just short term pilots. So, next is the regulatory frameworks. As with any technical shift in finance, standards and compliance must evolve in both ways. So, the government, central banks, and also the industry bodies will play more critical role in shaping these policies and setting these benchmarks and also the supporting safe innovation. And finally, the transition planning is the key here. So we can't flip a switch from old to new systems overnight. So a phased approach, starting with hybrid models and gradually introducing post-quantum cryptography is the most practical and secure path forward. So the institutions that start preparing today will be best positioned to lead tomorrow. So quantum isn't just coming, it's like just accelerating. And the financial sector also must keep up with the pace. So as we conclude here, so what I would like to say is that the timeline is pretty clear as we have discussed in the previous slide. So within the next decade, the quantum computing will transform how the payments work, making them exponentially faster, smarter, and more secure. So the early adopters, those who experiment, invest, and plan today will gain a massive competitive edge. These institutions won't just keep up with the change, they'll also help define it. And most importantly, the leap isn't just about the systems. It's more about people, how they can adopt to it. So the customer experience will be reimagined, the instant transactions, predictive security, the seamless cross-border transfers, the trust, and also the convenience at a whole new level. But to get there, we definitely need a good strategic planning now. So from encryption upgrades to the workforce readiness, from policy to platform, this journey requires foresight, coordination, and a bold leadership. So quantum isn't just a technological evolution, it's a financial revolution going forward. So it's time we start looking forward and build towards it. Thank you so much for the attention, and I'm happy to answer any questions, and I'm happy to get connected on LinkedIn if anyone is interested to know more about how quantum computing is really revolutionizing and how it is getting really adopted in some systems.